We're now going to obtain the graph of a sinusoidal function. The first thing that we have to do for the graph of y equals 4 times the sine of 2x minus pi is figure out the amplitude. The amplitude is the absolute value of a, the coefficient on the sine function. So the absolute value of 4 is 4, so the amplitude is 4. The period of this function is 2 pi over omega, where omega is the coefficient on the variable x. So we have that the period is 2 pi over 2, or pi radian. Finally, we want to know the phase shift. The phase shift is phi over omega, where phi is the value following the subtraction sign, so that's pi. And omega, again, is the coefficient on the variable 2. So the phase shift is pi over 2. What this basically means is rather than the graph starting at x equals 0, one cycle of the graph is going to begin at x equals pi over 2 and will end pi radian later. So to obtain the graph, what I'm going to do for starters is refer you to the graph of the general sine function. Notice that the graph starts at 0, 0, and one complete cycle ends after 2 pi radian. That's because the period of this function is 2 pi radian. The period of the function we're trying to graph is pi radian, so instead of requiring from 0 to 2 pi to do one cycle, we'd only need to go from 0 to pi. Or in general, we'd only need pi radians to do one cycle. Because of the phase shift, that's causing one cycle, instead of beginning, like I said, at x equals 0, it's going to begin at x equals pi over 2. So let's see how this is going to pan out for us. We use the phase shift, and we're going to say that one cycle begins at pi over 2, the value of phi over omega. Because of the fact that the value of a on the sine function is a positive 4, we know that we're going to increase until we reach a high point of 4. We then decrease and decrease again, going to low point of negative 4, and we end up back at the beginning of a cycle again at 3 pi over 2. Notice that from pi over 2 to 3 pi over 2 is exactly pi radian. That is the value of the period. So what are these points exactly? Well, if you recognize that from pi over 2 to 3 pi over 2 again is pi radian, we basically have a few key points on the graph. You could think of this as the increasing point is one interval, here to here is two intervals, here to here is a third interval, and from here to here is your fourth interval. So take the interval from pi radians and divide it into 4. So each subinterval is of length pi over 4 radian. So from pi over 2, or 2 pi over 4, to here, pi over 4 more radians, puts me at 3 pi over 4. So this point right here is the point 3 pi over 4, comma 4. Then another pi over 4 radians puts me at pi, comma 0. Another pi over 4 radians puts me at 5 pi over 4, comma negative 4. And then another pi over 4 radians puts me at 6 pi over 4, or 3 pi over 2. Once you have this full cycle in, you just continue that same pattern to trace in a complete graph.